7.3 is logarithms. That's how you pronounce that word, logarithms. Okay? And a logarithm is really just another way to represent a power.
Let's go.
Okay? Now I'm going to put something on the screen. You can take a picture of it. You can also screenshot it from your book. It is on page 1068. And then once you get that all situated in your notes, I will talk about what's all going on here. So there's some things that we want to focus on here and talk about what means what and where it goes. We are used to this notation, okay? We're used to seeing things as an exponent base to the power equals a number, okay? The logarithm itself equals the power. So notice over here it says log, and I'll talk about how to say this, that equals y. Y is the power. So what's going to happen is the base and the power in terms of its size are going to change roles. So we're used to the base being the bigger number and the power being the small number. When we write it in log form, logarithm form, the base becomes the little small number and the power becomes the bigger number. Okay? So all this arrow is just trying to line up the things and show you where they go. And so most of 7.3 is taking things that are written in exponential form and converting it to logarithmic form, or going from logarithmic form and writing it as an exponent. Okay, that's what 7.3 is all about, getting you used to the notation, getting you used to the mechanics, getting you to understand where everything goes. Now, a couple things that you need to keep in mind. B and X, so the numbers next to the log, those have to be positive. If either of these numbers end up being negative, you have a problem. The other thing is that B cannot equal 1. All right, so the base can never be 1. Both of these numbers have to be positive. And later on when we start solving equations, you're going to have to do checks. And if either of these things end up being non-positive, meaning 0 or negative, or b equals 1, we're going to have a problem. We're going to get rid of those things. Okay? So, notice here, if I have something written as an exponent, b to the y equals x, when I rewrite it, we say this is log base b of x. So log base b of x equals y. And yes, the log button on your calculator means logarithm. That being said, we actually won't get to that button on your calculator until I think it's 7.6. Okay? But when we get there, I will show you how to use that button. Okay? So notice over here they give us an example. 3 to the y equals 27. So the log equals the power. All of this over here is the log. That equals the power. So that's why the power over here is y. The base becomes the subscript, the little number, and the answer goes next to it. Okay? So the key thing here is just making sure that you loop it around properly. This becomes the base, this becomes the power, 3 to the y equals 27. It's almost like it goes kind of in reverse order. 3 to the y, and then it cycles back, equals 27. Okay, so that's how logarithms work. That's the way that we rewrite things from logarithmic form, which is this. This is logarithmic form here, to exponential form, and this is exponential form. Okay, you're going to have to keep it straight. For the most part, it should be pretty easy. You know that if it asks for logarithmic form, there's going to be the word log in there. If it asks for exponential form, then you're going to have exponents there. Okay? So let's look at some examples and we'll go through what we're supposed to be doing. Okay? So here you have two equations that are in exponential form. Right? We have exponents. So all we're doing is writing this in logarithmic form. So just do the first one for now. Okay? Try to write that using log form and follow the order from the previous slide. So go ahead and try that one. Remember that a logarithm is a power. So two things that you can think of. Okay, first of all, obviously we have to put the log there somewhere, right? The base becomes the little number, the power goes on the other side. So I kind of loop it back around, okay? So the base becomes the little number, the power goes over here, and this number goes there. So this should look like, okay? Okay, so again, a logarithm equals a power. Notice that this logarithm equals the power of 3. And so, again, you can kind of loop it backwards. 15 to the third equals 3,375. The base will become the little number. The power will become the number on the opposite side of the equal sign. How many had that one right? Okay, and that's, for some of what you're doing today, that's all you're doing, is getting used to writing it in logarithmic form or exponential form, depending on which way they give it to you, okay? So the second one, all right, again, it's in exponential form, so go ahead and write that in logarithmic form. So again, the base becomes the little number, the power becomes the number on the opposite side of the equals, and the answer sort of sits in right next to the log. So you should have gotten log base 4 of 2 equals 1/2. How many had that? Okay, so that's all there is to converting from exponential form to logarithmic form. All right, let's go the other way. Okay, now I'm going to give it to you in logarithmic form, and I want you to convert both of those into exponential form. Let's go ahead and do that. The thing that's nice about writing it in exponential form is you can tell whether or not you've written it correctly because it will be a true sentence. So for example, on this first one, 2 to the third equals 8. We know that 2 to the third does equal 8, so consequently I did it right. For the most part, you're going to know that. How many had that one right?
So you can even like check yourself?
Yeah, so you can check it real easily, right? If you would have written, let's say, 8 to the third equals 2, obviously 8 to the third does not equal 2. You did something wrong. Now, granted, in the next one where you have negative powers, it might not be as easy. 4 to the negative fourth equals 1 over 256, okay? Which just means 1 over 4 to the fourth. So that, is again, is a true statement. Okay, how many had that one? All right. So the other thing that we will do is evaluate a logarithm. Okay, and here's the deal with this. Okay, as I said before, a logarithm is just a number that happens to represent a power. Okay, so a logarithm is a power. So we're looking for a power, and when we do this problem, this log base 16 of 4 equals a number. And here's how we want to think about it. And I'm going to write it this way and specifically write in the word think because you're not really solving an equation. But you're thinking to yourself, okay, I have to raise 16 to some power and it has to equal 4. What's the relationship? How can I take 16 and take it down to 4? Okay, well, but the problem is I'm raising it to a power. I have to raise it to a power. 1/2 power. Why do you say 1/2 power? Okay, right. So the square root of 16 is 4. And if you recall, when we did this in chapter 6, the 1/2 power means square root. So in this particular problem, okay, it equals 1/2. Now, here's what's important. I said it equals 1/2, but there's no equal sign. You can write this out if you want, but we're not solving an equation, okay? I want you to be real careful. There's no, random x equals 1/2. It's just 1/2. There's no x in the equation. There's no question mark in the equation. If you want to think about it this way, even if you want to write it down, that's fine, but there's no question mark equals 1/2. This just is a power, so my answer is 1/2. And so when we see the word evaluate, you're trying to come up with a specific number. Okay? Let's look at another one. Okay?
Are we supposed to put that in our calculator?
You're not. There is no calculator work here. This is all in your head. It's all trying to figure out what's going on here.
Log 3.
Yep, that's log base 3 of 81. So we're trying to figure out what the power is. We're going to raise 3 to some power and see if it will equal 81. So you need to find out what that power is. Now, in this case, you could guess and check a little bit, okay? You could guess and check. You could try to figure out, again, we're trying to think, 3 to what power equals 81?
4.
Okay, and so you could use your calculator, guess, and check until you figure it out. At this point, hopefully we know that 3 to the 4th does equal 81. So log base 3 of 81 is 4. Okay, it's not question mark equals 4, it's not x equals 4, it's just 4. Okay? So those are the three things you're doing in section 7.3. We're converting from exponential form to logarithmic form. We're converting from logarithmic form to exponential form, and then we are evaluating logarithms. Okay? Any questions about any of that? Pretty straightforward.
Is that all we're doing today?